So part B is saying in the diagram below, two cables AC, BC are connected at C at the location of a load. With the aid of a well-labeled free body diagram, calculate the tension along AC and CB. Take 1 lb will be equal to 1 Newton. So I guess with that, we're supposed to use it when referring to the mass of the load there. We're supposed to convert it into newtons. That means 200 newtons will be equal to the weight of our load there. Okay, so we can put out a free body diagram. How is it going to be? We have such a diagram. Okay, like this. Then there's an angle here of 40. There's an angle here of 30. Then we have A there, we have C here, we have B here. The load is here, and you said the weight of the load is 200 newtons, like that. So there is tension here, since it is pulling on the middle here. That means there is tension pointing in this direction and also tension pointing in that direction. So let's now resolve our tensions. If we have tension, or if we have these tensions, what are we going to see? We're going to find that AC, which is the tension on top, will be in two axes. There will be one pointing up and one pointing in that direction. So this one, which is here, since here it's 30, that means even here it's 30. These are Z angles. So this one is adjacent to the 30, so it will be what? It will carry a cosine. So we're going to say AC cos 30, plus this one will be AC sin 30. Then the other one here, which is BC or CB, it is also in these two axes. That one and that one pointing down. So since here it's 40, that means even here again it's 40, because these are Z angles. So since this is the one which is adjacent to the 40, is going to carry a cosine. So this one will be CB cos 40, and down here it will be CB sin 40, like that. So here we have resolved our two tensions. This diagram, or the objects in this diagram, are at equilibrium. So what can we do? We can now bring our second law of motion, and since these guys are at equilibrium, there is no acceleration anywhere. That means they are equal to zero. The summation of the forces are equal to zero. So let's look at the forces that are in the x-axis. Summation of forces in the x-axis will be equal to zero. And what forces are in the x? It is this guy which is here and this guy which is here. So I'll say my summation of the forces in the x. This one is in the negative direction. That one is in the positive direction. So I'll say CB cos 40 is equal to what? Is equal to AC sin 30. Like that. Those are the forces in the x-axis. Then the forces in the y, we have this guy which is here, and these two forces that are here. The weight and the vertical component of tension CB. So I would get my AC as the positive because these two are pointing down. So I'll say AC cos 30, summation of forces in the y, is equal to 0 also. So I'll say my AC cos 30 will be equal to what? It will be equal to 200 Newton plus CB sin 40. CB sin 40 like this. So you can see to say in both of our equations in the x and the y axis, what we are missing is AC and CB. So what can we do as usual? We can just use a system of simultaneous equations in order for us to find either of them first. We're going to find them one by one, either starting with CB or starting by AC. So what am I going to do? Let's make AC here the subject to the formula. And by so doing, we're going to divide both sides by sine 30. Even here by sine 30. Sine 30 will cancel out there. We're going to have AC is equal to what? It is equal to CB cos 40. CB cos 40 over sine 30 like that. Okay. And we can divide cos 40 and sine 30 in advance so that we simplify our equation, because we know to say these two are numbers. The letters are CB here. And if I do so, I'm going to get my AC is equal to, if I divide cos 40 divided by sine 30, I'm getting an answer of 1.532. So this will be equal to 1.532 CB, like this. So this is the value of AC. And I can just get that value of AC and plug it into this equation that we had in the y-axis. Okay, and if I do so, what am I going to do? Or what am I going to, I'll plug it there where there's AC. So I'll say 1.532 cos 30 this is CB multiplied by cos 30. This will be equal to 200 plus CB sine 40 plus CB sine 40, like that. So here I can multiply 1.532 multiplied by the cos 30 there. And what am I going to get? I'm going to get 1.326 CB being equal to 200 plus CB sine 40, like that. Okay. After doing that, what are we going to do? We can transfer this guy to the right hand side or to the left hand side of our equation. I'm going to find 1.326 CB minus CB sine 40. And this will be equal to what? Will be equal to 200, like that. So what is the value of sine 40? Sine 40 is equal to 0.64. So I'm going to have 1.326 CB minus 0.64 CB. This will be equal to 200. If I subtract those two, I'm going to get 0.684 CB being equal to 200. Divide both sides by 0.684. This will cancel out. Even this side over 0.684. I'll get my CB, which is the tension CB, being equal to what? That guy is going to be equal to 291.54 newtons. That is my tension CB. And if that is the tension, I'll just get that value and plug it into this equation here. SC is equal to 1.532. SC will be equal to 1.532 multiplied by CB, which is 291.54. SC will be equal to what? Or SC rather. SC will be equal to 446.2 0.67 Newton. Okay, so that is the value of the tensions SC and CB when we calculate, starting by drawing a free body diagram, which is looking like this. All right, so that was all about question 2. Question 2 was also a bit long, but we can now move on to question 3.